So, very good morning, guys. Today we're talking about one of the very important and interesting concept. Most of the students struggle a lot in kinematics graphs. So, today I will tell you how to handle the graphs in short manner as well as tips I have to tell you the people. Let's see one by one. So, today we're talking about kinematics, kinematics graphs, kinematics graphs we have been talking about today. Today we are talking about the kinematics. This is very interesting. So before entering the kinematics graphs, let's see what is input graph first. So let's see what is input graph. So see guys, there are different styles of graphs is available in the market, but we are talking about in terms of a line graph. We are more discussing about a line graph. So let's see guys here. This is x-axis. So this is x-axis here. This is the y-axis. This is origin. So this is origin. So generally, when you're talking about graphs, everybody must learn about origin, y-axis, x-axis. This is very important things actually. So y-axis, x-axis, origin. So let's see guys here. Generally, when you are tackling these graphs, we want what is the plotting on what is the physical quantity which is plot on x-axis? What is the physical quantity which is plot on y-axis? Suppose let's say an example. I want to consider displacement time graph. Displacement time graph. Displacement time graph. So I am taking this graph. So in the graph, there is a two physical quantities is there. One is displacement, second one is the time. So we have two physical quantities here. So time is one of the physical quantity and displacement is another one physical quantity. So which one you have to plot the which axis? So that is very important here actually. That is very important. So generally in physics, one thing must be learned in people. General physics on x-axis, we will always plotted independent quantity, independent quantity. So independent quantity you have to place the independent quantity you have to place the x-axis. So that is very important. I want to plot displacement to time graph. Which one you have to plot? Compulsory independent quantity you have to plot on x-axis. So these two, this displacement time which is independent. So generally time is not waiting for anybody in the universe. That is universal truth. So time is an independent quantity. So we have to plot on x-axis time I have to so time I have to plot an x-axis. So remaining is what? Displacement. So displacement generally on y-axis plotted independent quantities, dependent quantities. So generally dependent quantities we have to plot on y-axis. So independent quantity we have to plot it on x-axis. Dependent quantities, plot on y-axis. So according to that, so on x-axis time and y-axis is displacement. So displacement is also called as position. Generally, displacement is also called as what here? Position. So position we call it as. So first thing is very clear. So how to draw a graph? Let's see guys here. I have to consider the data. Let's see one example so that people are understood. So I have to take a data of so let's see. So this is T and this is let us say displacement. Can I quote with displacement D? Displacement T. Okay. Otherwise, yes. Generally, the textbook we found as now we are confusing other people. So yes. So let us say zero. So what is the displacement? Zero only. So object is at rest. So now let's try to move. First seconds. Let's go with two meters. So this is in meters. And this is in seconds. So let us do 3 meters. So shall I go 0 to 4 now? 4. And 3 seconds we go with 6. And 4 seconds we go with 8. So I have to take a graph in time on x-axis 0, 1, 2, 3, 4, and respectively the displacement is happening. For 0 to 0 and 1 to 2, 2 to 4, 3 to 6 and 4 to 8. Now I draw the graph. When you want to draw the graph, what you have to do? First thing you have to do, you have to draw x and y axis. Now I am drawing x and y axis here. So this is x axis. This is what here? Y axis. Second thing is that we have to make the units, the division of this graph, we have to do it. Let's see here. What is the time? This is the time, and this is what here? Displacement. Yes. So now here observe you people 0, 1, 2, 3, 4. So on x axis, so 1 unit is equal to how much we have to bring? 1 centimeter. So how to do this one? So starting with 0, and this is 1 here, this is 2, this is 3, and this is 4. 4 is there here only. Next you go with 5 better. So this is go with 5. That is x-axis. Let's see on y-axis. Displacement start with 0, 2, 4, 6, 8. Even number. Let's see we have to do with that. On y-axis, 1 unit is equal to 2 centimeters. So I am considering 1 unit is equal to 2 centimeters. So what will happen now? This become 2, this become 4, this become what here? 6, this become 8. So this is yes. Now what you have to do? Let us say 0 to 0. So we have to make a point 0 to 0. Here is the point. And 1 to 2. And 1 to 2. So 1 to yes, 1 2. And 2 to 4. So 2 to 4 here. 2 to 4 good. And 3 to 6. So here 3 to 6. So they are not here. I hope it is here. Okay. Next 4 to 8. I hope from 4 to 8. This. So I drawn a line. So this is the way we have to draw the graph. So one thing we have to understand from the graph. So graph has two parts. One is x-axis and y-axis. In physics, generally x-axis plotted on independent quantities, and second one y-axis plotted on dependent quantities. I hope people are understood there. So let's see now we move on to actual kinematics graphs. I actually kinematics. Generally in kinematics, we have three types of graphs are there generally based upon physical quantities what you are using. So which is having three types of physical quantities. Let's see first one xt graphs. So xt graphs or position time graph. Position time graph. Position time graph or displacement time graph or displacement time graph. Second one is that VT graphs. So VT graphs. So VT graph or velocity time graph. Velocity time graph. Velocity time graph. Next. Third one is that acceleration time graph. Acceleration time graph or acceleration time graph. So these are all three types of graphs which are there in kinematics. So first one is what here? xt graph. Second one is what? vt graph. Third one is what? at graph. So this is sometimes we called as st graph also. Depends upon the book how author is decided what the displacement is talking with s. We go for st graph, and author will be decide displacement talking about x. So we go with what? X only. So So this is the three types of graphs. Three types of graphs which is there on your kinematics graphs. So let's see guys here one by one. Now we move on to the XT graph. So first one, move on to the XT graph. So I want to go with XT graph. So XT graph. So in the XT graph generally, let's see guys here, we take XT graph. So I'm taking XT graph. So what is the XT graph guys? This is x-axis. This is what here y-axis. And this is what here origin. So generally what you have to plot on x-axis, I tell you just now, independent. So what is the independent here? Time is the independent. And here what you have to place x. So generally see guys here. Now I want to find out the slope. Let's see what we'll get. Slope m is equal to slope m is equal to what is the formula guys? Y by x. Y by x. So y physical quantity by x physical quantity. What is the y here? X by what is x here? T. So nothing but what? Displacement by time. Displacement by time. Agree? Displacement by time. So displacement by time is what? Velocity. So velocity is equal to x by t. So from xt graph, we have to get a slope. We have to get a slope. Ultimately, what we have to get? Velocity we have to get. Velocity we have to get. From this x is equal to vt. So this is very important. This is very important. X is equal to vt. Second one, I am taking a chord now. I am taking a chord. So I draw a chord here. Let us say AB. I am taking 2 points. Now based upon the chord gives average speed. Average speed. So average speed or average velocity of wish. Average velocity. I am taking a distance graph, we get a speed. I am taking a displacement graph, we are taking what? Average velocity. So because of chord. So what you have to get? Average speed or average velocity you have to get. So where you have to get the points here? A and B. Because of these two points, we get what? A chord will be generated. This is the chord here. Because of this chord, what you have to get guys? Average speed or average velocity. So let's say guys here, we have to observe x is equal to vt. So when we are observe x is equal to vt, So x is equal to vt, how it look like guys? In the form of y is equal to mx, which is there in our mathematics coordinate geometry, y is equal to mx. It shows a line passing through origin. So x equal to vt graph shows that y is equal to mx. What is the meaning of it? A straight line which has a slope of m and passing through origin. So very important. Passing through origin. This is very important. Let's see guys here. Another manner of straight line equation is also there. What is straight line equation guys? Y is equal to mx plus c. This is another type of equation to represent a straight line. So what is the meaning of it? How can I get from your x is equal to v? Generally we know displacement is equal to what guys? Displacement x is equal to what is the meaning of displacement? Displacement is nothing but final position minus initial position. So I hope when you have seen the vectors, generally when you are using vectors, the positions, so x is equal to x of minus x naught. So what is the meaning of x of? Final position minus initial position. Now I have to substitute in the place of x. So what you have to get? So I have to place here. So x is equal to what is x value guys here? Xf minus x naught is equal to Vt. So what you have to get from this, xf is equal to x naught plus Vt. I hope people are understood. So xf is equal to x naught plus Vt, which means it resembles y is equal to mx plus c model, c plus mx, yes or not? So it is resembles a model of y is equal to c plus mx. So what is the meaning of it? So what is the meaning of it? What is the meaning of that actually? So what is the meaning of that? So let's see meaning of that. So what is the meaning of y is equal to c plus mx? Y is equal to c plus mx. So the meaning is that y is equal to c plus mx, a straight line, a line which is passes through O comma C, which is passes through O comma C, which is passes through O comma C, and having a slope, and having a slope, of m, having a slope of m. So this is the meaning of y is equal to mx plus c. Y is equal to mx plus c. So according to that, so what can I write here? Xf is equal to x naught plus Vt. X naught plus Vt. Let's see one by one. What is the first equation? So what is the first equation, guys? The first equation is that x is equal to, simple in the form of Vt, which resembles y is equal to mx. So here the intercept is 0, here also intercept is 0, but here y is equal to c plus mx. So what is the intercept here, guys? X naught is the intercept, and what is Vt? What is slope? M is equal to v. Here also, what is intercept? 0, but m is equal to v. Now I want to draw this equation. Let's see, guys, here. Now I want to draw these equations. So let us say this is time, this is x. X means position. Keep in mind. So this is 0, this is 0. So now what you have to do? We draw a graph with the intercept x naught, Suppose can I my intercept x naught here, assume my intercept is x naught here. So it is a straight line. So we have to get a graph like this. It shows we have to get a graph like this. And second one, let's see, observe here. The second one, how to get a graph. So this is the way we have to get a graph. This is the time t, and this is position. So what is the intercept now? Intercept becomes 0. So where you have to start? You have to start from here only. So this is x f is equal to x naught plus Vt line. This is Vt line, and this is what, guys? X is equal to Vt. So why? Because this is the origin. So this is the way we have to get a line which is passes through O comma C and having a slope of m. Next one is that suppose we have a quadratic equation. So let's see an example. X is equal to ut plus half at square. So which is in the form of what, guys? Which is in the form of ax square plus bx plus c. So ax square plus bx plus c. So what is the meaning of it? So when you have a quadratic equation is there, generally what type of graph you get? The graph should be a parabola. So the graph should be a parabola. Which type of parabola? Either downward parabola or upward parabola. How to decide? Based upon the a value you have to decide. So a greater than 0. A greater than 0. So what type of parabola we get? So a value becomes a positive. What type of parabola we get? So a greater than 0, we get a parabola named as upward parabola. Upward parabola. Suppose a value less than 0, what you get? A value less than 0, what you get? So upward parabola, this is what you get, less than 0. Downward parabola. So this is the way we get. What is upward parabola? Let's see, guys, here. So upward parabola. So this is upward parabola, na? This is upward parabola or not? Yes or not? This is upward parabola. So this is t I am considering. This is what? X I am considering. So now what will happen? This one. So this become what? This become what, guys? So let's observe here. So we have x is equal to ut plus of 80 square. Ut plus of 80 square. Why? Because it is 0 here. So next how we get this one? Let's say this one. This becomes a downward parabola. So downward parabola. So let's see, guys, here. This is a downward parabola. Downward. So this is downward parabola. So you want to get a downward parabola here. I want to get it down. This is a downward parabola. This is what? Upward parabola. So upward parabola, when you get a less than 0. So a is negative, we get a downward parabola. A is positive, what you get? Upward parabola. So I hope you understood till now, guys. Let's move on to the actual concept. These are the basic concepts we need for knowing about parabola. So I want to talk about parabola. This is the mathematical concept which is requires these people to understand the graphs in kinematics, obviously. So now we move on to position time graphs first. So position time graph. So position time graph. So in the position time graph, so the first graph is what? Particle at rest. So particle at rest. Particle at rest. So particle is there at rest. So how to handle? So when particle there is at rest, how can draw the graph? Let's see, guys, here. Once again, this is position time graph. Let's see, guys, here. So this is what here time. This is what x. X is nothing but position. Position. Now, so this is what here 0. So let's assume, guys, here now. So one object is there. So let's say one car is there. Assume one car is there. One car. One car is there. So now the position of this car, let us say x naught is equal to starting with 5 meters. X naught is equal to 5 meters. So it moves from this point to somewhere else. So now the particle at rest itself. So where it exactly there, x naught is equal to 5 meters. So it's starting from its starting point. So starting point. Now let us say 1, 2, 3, 4, 5. Let us say 1, 2, 3, 4, 5. So let's see, guys, here now. So this is what here? X, position of object. So position of an object. Let's see, guys, here now. On 0th second, where will be there? 0th second, how much distance is traveled? 5 meters. Now the object is here. I hope. Next, on 1 second, there is no change in the object position. So 5 only. And 2 seconds, 5 only. 3 seconds, 5 only. 4 seconds, 5 only. 5th second, 5 only. So what we get? So a straight line which is parallel to x-axis we get. A straight line parallel to x-axis. Because of what? Because of what, guys? Because of what? So because of what you get? So which is rest. So there is no motion of an object is takes place in here. There is no motion of an object is takes place in. That is the way what we have to get here. So what we have to get, Nana? What we have to get? A line which is parallel to x-axis. Next, see next one. Next one, guys. Let's see next one. Particle with uniform motion. So particle with uniform motion. So particle with uniform motion. So particle with uniform motions. So let's see, guys, here particle with uniform motion. So which is the meaning of it? Let us say I want to calculate x value. So now which there are. So let's say the same car x is equal to x naught, which is traveling this car. With this traveling this car with the same with the traveling this car with uniform motion. So uniform motion. So it is having uniform motion. So let us say x is equal to xf. So what is the state of this one? Uniform motion. So what is meant by uniform motion? So equal intervals of times covered equal displacements. So equal displacement is called uniform motions. So now how to tackle? Let's say guys here. So let's say guys here. So x is equal to x is equal to x. What is the meaning of it? X initial how much? X naught and x final xf and t is equal to t is equal to t. Generally we know guys. So what is the formula for x? X is equal to vt. Just now we have to see x is equal to vt. So what is the x value? So how to find out the displacement? So displacement I want to find out. So displacement x is equal to final position minus initial position. What is the initial position? X naught. Keep in mind, guys. So this is vector related. Vector that is I am considering as the positions. So xf minus x naught. So in place of what you are supposed to write xf minus x naught is equal to vt. So xf is equal to vt plus x naught. Agree? Vt plus x naught. So how it look like? How it look like the equation? So y is equal to mx plus c. So what is the intercept here? X naught is the intercept. What is the slope of that? V. Now we draw it. So just now I had to tell you now, you people. So I already told you people that y is equal to mx plus c. It is a straight line passes through intercept. What is the intercept here? So let us say this is x naught. So it is moving like this. It is moving line. So this is the what guys. So this is the line shows us xf is equal to v naught plus x naught. So v naught plus x naught. So this graph shows that xf is equal to v naught plus x naught. Let's see the third graph. So particle with uniform motion, but initial position is 0. So particle with uniform motion, with uniform motion, particle with uniform motion, x naught is equal to 0, x is equal to x, and t is equal to t. Now how to handle this situation? Let's say guys here. Now substitute in this case. So xf is equal to x only, and vt remains vt only, plus x naught become what guys? 0. Now what you get? X is equal to vt, which is the form of what? Y is equal to mx. So graph what will happen now? Y is equal to mx. Once again we draw a graph. We are plotting x-axis t and we are plotting y-axis at x. So which is starts from 0, which is passes through this straight line which passes through origin. So we have to draw here. So x is equal to vt. So keep in mind this is x equal to vt line. So x is equal to vt line. Let's see next one. So let's see next one guys. So what is the fourth model? Let's see the fourth model. So what is the fourth model? So fourth model is what? So uniform acceleration. So uniform acceleration. So particle is moving with the uniform acceleration. Then what guys? So x is x, that is initial. X initial is equal to x naught. X final is equal to xf only, time t is equal to t only. So uniform acceleration. What is meant uniform acceleration guys? Generally uniform acceleration in equal intervals of times there is an equal velocity. Generally equal velocities, otherwise the acceleration is constant. So let's see an example. So I am quoting here. So generally the equation which is suiting for uniform acceleration is x is equal to ut plus half at square. Half at square. So generally x is the position. So how we find out the displacement? Simple. Generally I told na xf minus x naught is equal to ut plus half at square. So I want xf here. So xf is equal to half at square plus ut plus x naught. I hope you understood, you people. Xf is equal to of 80 square ut plus x naught, which is the equation in the form of y is equal to ax square plus bx plus c. So which is in the form of y is equal to x square plus bx plus c, which means what guys? Generally I told a greater than 0. So what you get? Upward parabola, downward parabola, upward parabola. So this is an upward parabola. Now we have to draw it. We have to draw it. But what is the intercept here? What is the intercept? X naught is the intercept. So x naught. So this is t value. This is x value. Now it is upward parabola. Upward parabola. So this is upward parabola. So this is what guys? Xf is equal to half at square plus ut plus x naught. So very important. So ax square plus bx plus c. Xf is equal to half at square plus ut plus x naught. Let's look at here. It is increasing slope or decreasing slope? I want slope. I want slope nature. Slope nature. I want to measure a slope nature. So it is increasing slope or decreasing slope? So tell me guys. Tell me anybody. It is increasing slope or decreasing slope? Slope. What type of slope which is have it? So simple technique. Take a palm of you people and apply on that. So it is towards the y-axis or towards the x-axis we have to decide. So we have to take a palm and place here. It is a towards x-axis, other towards y-axis. Suppose it is towards y-axis, it is an increasing slope. Increasing slope. So keep in mind, guys. So once again, I am telling you guys, take a palm, put over there, put over the curve, and how it moving towards the y-axis, other towards x-axis. It is moving towards y-axis, increasing slope. Towards x-axis, decreasing slope. So next one, guys. Next one, we move on to the next one. We move on to the next one. So uniform acceleration. Uniform acceleration. Uniform acceleration. Uniform acceleration. Uniform acceleration, but x initial is equal to 0. So this is the fifth graph. X initial is equal to 0, xf is equal to x, t is equal to t. Now what is the equation now? So let's substitute here. So xf means x only. So x is equal to half at square plus ut plus 0. I am substituting in this equation. So what you get? X is equal to half at square plus ut. So which is the form of which model? Once again, guys, this is the form of which model? Y is equal to ax square plus bx plus c. The same one. We put 0 no issue na ax square. So what type of graph you get? Once again, parabola. A is positive. So what type of graph you get? It is upward parabola, but passes through origin. Passes through origin with increasing slope. Keep in mind, guys, we get increasing slope. Why? Because once again apply the rule. So we have to put our palm on over here, and what the direction of the curve? The direction of the curve is towards the y-axis. So when towards the y-axis, what type of slope we get? Increasing slope. So increasing slope in what is the meaning of it? So velocity is increasing. That is the meaning of it. Velocity is increasing. This is the position. So this is the what? This is what, guys. So y is, that is x is equal to half at square plus ut graph. So ut graph. Next, now move on to the uniform retardation. How will happen the uniform retardation? What is the nature of the uniform retardation? Now we move on to the next graph, that is the sixth graph. Sixth graph, guys. We have to go with the sixth graph. Uniform retardation. So uniform retardation. Uniform retardation. So with values are once again xi is equal to x naught and xf is equal to xf only and t is equal to t only. Now I want to draw uniform retardation. What is about uniform retardation? Negative acceleration. So negative acceleration. Negative acceleration. What is the meaning of it? Negative acceleration. Generally, when you're talking about retardation, so A is equal to, so U greater than V. So this is the case generally, U greater than V. So initial velocity is more compared to final velocity. Then initial velocity more compared to final velocity, generally we have an acceleration is a retardation generally. So what you get guys, what is the formula for A? A is equal to V minus U by T, but U is greater, so minus taking common, U minus V by T, so what you get? Minus A. So negative acceleration, this negative acceleration is called what? Negative acceleration is called what? A retardation. So retardation. So negative acceleration is called a retardation. So when retardation is there, when retardation, so what is the thing here? Uniform retardation. So we get a decreasing slope here. Now we have drawn a graph, decreasing slope graph. So let's see the equation, how turn into the equation. So let's see guys here how this equation will be turned out. Let's see we have to take the equation. So xf is equal to but what is the a value? Minus a. So minus a whole square plus of minus a whole square. No. So of a d square. So minus a into d square plus ut plus x naught. So what will happen guys? Minus of a t square plus ut plus x naught. So this is the case. This is the case. So what is the a value? A value is less than 0. What do you get? Decreasing slope we get. It is downward parabola we get. Now we draw the graph. We get a downward parabola. So this is t. This is x. So this is x naught. This is x naught. So I'm plotting on y axis is x. Now we get what? Downward parabola. Since this is the downward parabola. So this is the downward parabola. Let's see guys here, increasing slope or decreasing slope. Let's look once again. Take a palm, put on that. It is toward the x-axis. So it is what? Decreasing slope. So decreasing slope. Velocity is decreasing, which means we are going to the retardation. Decreasing slope. So decreasing slope. We are going with the decreasing slope. Keep in mind, guys. So once again, retardation with retardation with so retardation with uniform retardation, uniform retardation. So uniform retardation. So what is the meaning of uniform retardation, guys? So once again, x naught is equal to 0, xf is equal to xf, t is equal to t. How to handle this one? Let's see guys here. So xf is equal to minus half at square plus ut plus 0 with the shape of what? Y is equal to minus ax square plus bx plus c. See what is the value? 0. So how would draw the graph? So this is the t, this is the x. So now how would draw the graph? This is the decreasing slope once again. This is the decreasing slope. This is the decreasing slope. So this is xf is equal to minus half at square plus ut plus 0. So last one guys, last graph, seventh graph. So that is vertically upward body. So when you are vertical upward body, so what you get? Vertically upward body. So vertically upward projected body. Vertical upward projected body. So that is sixth one. So vertically projected upward body. So vertically projected upward body also same as here that the decreasing slope. So this is t, this is x. So this is decreasing slope. That is the decreasing slope we get. So I hope you understood. Thank you. Please subscribe my channel. Please share it and like it and comment. Thank you guys.